Children, welcome to today's episode on liquid state of matter. Let us learn about properties of liquids, in which we will first learn about volume of liquids. Children, a liquid has a definite volume but no definite shape. It always maintains its volume, whatever may be the shape and size of the container. The liquid remains confined to the lower part of the container in which it is placed. The molecules in a liquid are not free to occupy any volume available to them. Let us now learn about density. Since the molecules in the liquid state are more closely packed, the density is expected to be higher as compared to the gaseous state and lower than solids under a given temperature and pressure. Children, we will next learn about compressibility. Liquids are much less compressible than gases because the intermolecular forces are more as compared to the gases. Let us now learn about diffusion. Diffusion is the movement of the solute particles from a higher concentration to the lower concentration in a particular medium. Molecules in the liquids diffuse at a slower rate. In liquids, the molecules are quite close and there is comparatively less scope for the movement of the molecules.
ਲਿਕੁਇਡਸ ਅਤੇ ਗੈਸਿਸ ਵਿੱਚ ਡਿਫਿਊਜ਼ਨ ਦੀ ਦਰ ਨੂੰ ਕੰਪੇਅਰ ਕਰਨ ਲਈ ਅਸੀਂ ਦੋ ਜਾਰ ਲੈਂਦੇ ਹਾਂ। ਅਸੀਂ ਇਨ੍ਹਾਂ ਵਿੱਚੋਂ ਇੱਕ ਜਾਰ ਨੂੰ ਪਾਣੀ ਨਾਲ ਭਰਦੇ ਹਾਂ। ਦੋਹਾਂ ਜਾਰਾਂ ਵਿੱਚ ਲਿਕੁਇਡ ਬ੍ਰੋਮੀਨ ਦੀ ਇੱਕ ਡ੍ਰੌਪ ਪਾ ਕੇ ਇਨ੍ਹਾਂ ਨੂੰ ਡਿਸਕਸ ਨਾਲ ਕਵਰ ਕਰ ਦਿੰਦੇ ਹਾਂ। ਬੱਚਿਓ, ਹੁਣ ਅਸੀਂ ਕੀ ਵੇਖਾਂਗੇ? ਅਸੀਂ ਪਾਣੀ ਅਤੇ ਹਵਾ ਵਿੱਚ ਬ੍ਰੋਮੀਨ ਦੀ ਮੂਵਮੈਂਟ ਨੂੰ ਵੇਖਦੇ ਹਾਂ। ਜਿਸ ਜਾਰ ਵਿੱਚ ਹਵਾ ਹੈ, ਉੱਥੇ ਇਹ ਲਿਕੁਇਡ ਡ੍ਰੌਪ ਵੇਪਰਾਈਜ਼ ਹੋ ਜਾਵੇਗੀ ਅਤੇ ਜਲਦੀ ਹੀ ਪੂਰੇ ਜਾਰ ਵਿੱਚ ਫੈਲ ਜਾਵੇਗੀ। ਜਦੋਂ ਕਿ ਜਿਸ ਜਾਰ ਵਿੱਚ ਪਾਣੀ ਹੈ, ਉੱਥੇ ਇਹ ਡ੍ਰੌਪ ਹੌਲੀ-ਹੌਲੀ ਫੈਲਦੀ ਹੈ ਅਤੇ ਕੁਝ ਦੇਰ ਵਿੱਚ ਹੀ ਜਾਰ ਦਾ ਪਾਣੀ ਇਕਸਾਰ ਰੰਗੀਨ ਹੋਵੇਗਾ। This clearly shows that liquids diffuse at a slower rate as compared to the gas.
Children, let us now learn about evaporation. Evaporation may be defined as the process of conversion of a liquid into its vapors at room temperature.
The process of evaporation can be explained with the help of kinetic molecular theory for liquids. We know that the molecules in a given liquid are in a state of constant motion and possess certain kinetic energy as well. जबकि given temperature ਤੇ molecules ਦੀ average kinetic energy constant ਰਹਿੰਦੀ ਹੈ, ਪਰ liquid molecules ਵਿੱਚ ਸਾਰੇ molecules ਦੀ kinetic energy same ਨਹੀਂ ਹੁੰਦੀ. As a result, a certain fraction of the molecules present at the surface of the liquid have large enough kinetic energies to overcome the attractive forces of the neighboring molecules. Therefore, they will escape into the space above the liquid surface and will appear as vapors. This will also apply to the rest of the molecules on the surface. If the liquid is kept in an open vessel, evaporation will continue till it is complete.
Children, now that we have learned so much, let us learn about factors affecting rate of evaporation. All liquids do not evaporate at the same rate. The rate of evaporation of a liquid depends upon few factors, which we will discuss one by one. The first one is nature of the liquid. The rate of evaporation is closely linked with the nature of the liquid, that is, with the magnitude of the intermolecular forces of attraction. Greater the magnitude of intermolecular forces of attraction, lesser will be the rate of evaporation. Let us now learn about the second factor, which is temperature. The rise in temperature increases the average kinetic energy of the molecules, thereby making evaporation become faster. Children, let us now learn about effect of surface area on rate of evaporation. Since the evaporation takes place from the surface of the liquid, more the area available, greater will be the evaporation. Let us now learn about heat of vaporization. Heat of vaporization may be defined as the amount of heat required to evaporate a certain mass of given liquid at a constant temperature. If 1 mole of the liquid is to evaporate, then the corresponding heat required is known as the molar heat of vaporization. For example, molar heat of vaporization of water at 25 degrees Celsius or 298 Kelvin is 44.180 kilojoule per mole. Let us now learn about vapor pressure.
We have seen that if a liquid is placed in an open container, it evaporates completely. But if the vessel is closed or covered, then the evaporation is never complete. Initially, the level of the liquid falls, but after some time, it becomes constant and continues to remain as such. This may be explained as follows. ਕਿਸੇ ਓਪਨ ਕੰਟੇਨਰ ਵਿੱਚ ਲਿਕੁਇਡ ਦੀ ਇਵੈਪੋਰੇਸ਼ਨ ਕੰਟੀਨਿਊ ਰਹਿੰਦੀ ਹੈ ਕਿਉਂਕਿ the decrease in average kinetic energy or the loss of energy is compensated by the surroundings. Ultimately, container ਵਿੱਚੋਂ ਸਾਰਾ ਲਿਕੁਇਡ evaporate ਹੋ ਜਾਵੇਗਾ ਅਤੇ ਉਹ ਬਿਲਕੁਲ ਸੁੱਕ ਜਾਵੇਗਾ। ਪਰ ਜੇਕਰ ਲਿਕੁਇਡ ਵਾਲਾ ਕੰਟੇਨਰ ਕਲੋਜ਼ਡ ਹੋਵੇ ਤਾਂ ਸਥਿਤੀ ਇੱਕਦਮ ਵਿਪਰੀਤ ਹੋਵੇਗੀ। ਇਸ ਸਥਿਤੀ ਵਿੱਚ evaporating molecules ਐਟਮੋਸਫੇਅਰ ਵਿੱਚ ਨਹੀਂ ਜਾ ਸਕਣਗੇ। ਮੋਲੀਕਿਊਲਸ ਹਾਇਰ ਕਾਈਨੈਟਿਕ ਐਨਰਜੀ ਦੇ ਨਾਲ ਵੇਪਰਸ ਵਜੋਂ ਤਰਲ ਦਾ ਤਰਾਤਲ ਛੱਡ ਦਿੰਦੇ ਹਨ, ਜਿਸ ਕਰਕੇ ਇਨੀਸ਼ੀਅਲੀ ਲਿਕੁਇਡ ਦਾ ਵੋਲਿਊਮ ਡਿਕਰੀਜ਼ ਹੁੰਦਾ ਹੈ। ਇਹ ਵੇਪਰਸ ਲਿਕੁਇਡ ਸਰਫੇਸ ਦੇ ਉਰਲੇ ਸਪੇਸ ਵਿੱਚ ਕਲੈਕਟ ਹੋ ਜਾਂਦੇ ਹਨ। ਇਹ ਕੰਟੇਨਰ ਦੀਆਂ ਦੀਵਾਰਾਂ ਦੇ ਨਾਲ ਹੋਰ ਵੱਧ ਕੋਲਿਜਨਸ ਕਰਦੇ ਹਨ, ਜਿਸ ਕਾਰਨ ਲਿਕੁਇਡਸ ਦੇ ਸਰਫੇਸ ਤੇ ਪ੍ਰੈਸ਼ਰ ਵੱਧ ਜਾਂਦਾ ਹੈ। ਇਹ ਮੋਲੀਕਿਊਲਸ ਜੋ ਕਿ ਵੇਪਰ ਫੇਜ਼ ਵਿੱਚ ਮੌਜੂਦ ਹਨ ਵੀ ਲਿਕੁਇਡ ਸਰਫੇਸ ਨਾਲ ਕੋਲਾਈਡ ਕਰਦੇ ਹਨ। ਉਹ ਜਿਨ੍ਹਾਂ ਦੀ ਲੈਸ ਕਾਈਨੈਟਿਕ ਐਨਰਜੀ ਹੁੰਦੀ ਹੈ ਉਹ ਲਿਕੁਇਡ ਦੇ ਸਰਫੇਸ ਤੇ ਕੰਡੈਂਸ ਹੋ ਜਾਂਦੇ ਹਨ ਤੇ ਇਹ ਸਭ ਕੋਲਿਜਨਸ ਦੇ ਹੋਣ ਕਰਕੇ ਹੁੰਦਾ ਹੈ। ਵੈਸਲਸ ਵਿੱਚ ਲਿਕੁਇਡ ਵੇਪਰਸ ਵਿੱਚ ਚੇਂਜ ਹੁੰਦਾ ਹੈ ਜੋ ਕਿ ਇਵੈਪੋਰੇਸ਼ਨ ਹੈ ਅਤੇ ਜਦੋਂ ਵੇਪਰਸ ਵਾਪਸ ਲਿਕੁਇਡ ਸਟੇਟ ਵਿੱਚ ਬਦਲ ਜਾਂਦੇ ਹਨ ਤਾਂ ਇਹ ਪ੍ਰਤੀਕਿਰਿਆ ਕੰਡੈਂਸੇਸ਼ਨ ਅਖਾਉਂਦੀ ਹੈ। ਇੱਕ ਨਿਸ਼ਚਿਤ ਤਾਪਮਾਨ ਤੇ ਲਿਕੁਇਡਸ ਅਤੇ ਇਸ ਦੇ ਵੇਪਰਸ ਕੈਮੀਕਲ ਇਕੁਇਲਿਬਰੀਅਮ ਦੀ ਸਟੇਟ ਵਿੱਚ ਹੁੰਦੇ ਹਨ ਜਿਸ ਨੂੰ ਫੇਜ਼ ਇਕੁਇਲਿਬਰੀਅਮ ਵੀ ਕਿਹਾ ਜਾਂਦਾ ਹੈ। ਕਿਉਂਕਿ ਇਹ ਕਿਸੇ ਸਬਸਟੈਂਸ ਕਹਿ ਲਿਓ ਕਿ ਵਾਟਰ ਦੇ 2 ਫੇਜ਼ਸ ਵਿੱਚ ਮੌਜੂਦ ਹੁੰਦੇ ਹਨ। The pressure exerted by the vapors of the liquid in equilibrium with liquid at a given temperature.
Let us now have a look at the factors affecting vapor pressure. The vapor pressure of a liquid depends mainly upon 2 factors. These are the nature of the liquid and the temperature. Let us first learn about nature of the liquid. The vapor pressure of a liquid is linked with its nature, that is, magnitude of the intermolecular forces present in its molecules. When intermolecular forces are weak, the molecules will readily change into vapors, and the equilibrium vapor pressure will be high.
Let us have a look at the graph showing vapor pressure temperature curves of few liquids on which vapor pressure are plotted against temperature. I hope it is clear that at a particular temperature, the vapor pressure of diethyl ether is the maximum, while that of water is the minimum. Thus, the vapor pressure predicts the magnitude of the intermolecular forces. Higher the vapor pressure of a particular liquid, lesser will be the magnitude of these forces.
Children, let us now learn about effect of temperature on vapor pressure of the liquid. The vapor pressure of a liquid increases with the rise in temperature, increasing average kinetic energy of the molecules. Number of molecules having sufficient kinetic energy overcome the intermolecular forces of attraction. This will lead to a greater number of molecules in the vapor phase, and consequently the vapor pressure of the liquid will increase.
Children, let us now learn about boiling and boiling point. ਜਦੋਂ ਕਿਸੇ ਬੀਕਰ ਵਿੱਚ ਕੋਈ ਲਿਕੁਇਡ ਗਰਮ ਕੀਤਾ ਜਾਂਦਾ ਹੈ ਤਾਂ ਲਿਕੁਇਡ ਦਾ ਟੈਂਪਰੇਚਰ ਵੱਧ ਜਾਂਦਾ ਹੈ ਅਤੇ ਉਸ ਦਾ ਵੇਪਰ ਪ੍ਰੈਸ਼ਰ ਵੀ ਇਨਕਰੀਜ਼ ਹੋ ਜਾਂਦਾ ਹੈ। ਲੋਅਰ ਟੈਂਪਰੇਚਰ ਤੇ ਇਕੁਇਲਿਬਰੀਅਮ ਵੇਪਰ ਪ੍ਰੈਸ਼ਰ ਐਟਮੋਸਫੇਰਿਕ ਪ੍ਰੈਸ਼ਰ ਤੋਂ ਘੱਟ ਹੁੰਦਾ ਹੈ ਜੋ ਕਿ ਲਿਕੁਇਡ ਦੇ ਸਰਫੇਸ ਉੱਪਰ ਐਕਟ ਕਰਦਾ ਹੈ। ਨਤੀਜੇ ਵਜੋਂ ਵੇਪਰਸ ਜੋ ਕਿ ਬਲਕ ਆਫ ਦ ਲਿਕੁਇਡ ਵਿੱਚ ਬਣਦੇ ਹਨ ਉਸ ਵਿੱਚੋਂ ਕੁਝ ਹੀ ਲਿਕੁਇਡ ਦੇ ਸਰਫੇਸ 'ਚੋਂ ਬਾਹਰ ਜਾ ਪਾਉਂਦੇ ਹਨ। ਜੇ ਹੀਟਿੰਗ ਨੂੰ ਕੰਟੀਨਿਊ ਕੀਤਾ ਜਾਵੇ ਤਾਂ ਇੱਕ ਅਜਿਹੀ ਸਟੇਟ ਆਏਗੀ ਜਦੋਂ ਲਿਕੁਇਡ ਦਾ ਵੇਪਰ ਪ੍ਰੈਸ਼ਰ ਐਟਮੋਸਫੇਰਿਕ ਪ੍ਰੈਸ਼ਰ ਦੇ ਬਰਾਬਰ ਹੋਵੇਗਾ। ਇਸ ਪੁਆਇੰਟ ਤੇ ਜੋ ਵੇਪਰਸ ਲਿਕੁਇਡ ਦੇ ਅੰਦਰ ਬਣਦੇ ਹਨ ਉਹ ਆਸਾਨੀ ਨਾਲ ਬਬਲਸ ਦੇ ਰੂਪ ਵਿੱਚ ਰਾਈਜ਼ ਕਰਕੇ ਐਟਮੋਸਫੇਅਰ ਵਿੱਚ ਚਲੇ ਜਾਂਦੇ ਹਨ, ਜਿਵੇਂ ਕਿ ਇੱਥੇ ਵਿਖਾਇਆ ਗਿਆ ਹੈ। ਲਿਕੁਇਡ ਦੀ ਇਸ ਸਟੇਟ ਨੂੰ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਕਹਿੰਦੇ ਹਨ। ਜਿਸ ਟੈਂਪਰੇਚਰ ਤੇ ਬੋਇਲਿੰਗ ਹੁੰਦੀ ਹੈ ਉਸ ਨੂੰ ਲਿਕੁਇਡ ਦਾ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਕਹਿੰਦੇ ਹਨ। At this temperature, the vapor pressure on the liquid surface is equal to the atmospheric pressure. Thus, boiling point of a liquid may be defined as the temperature at which the vapor pressure on the surface of the liquid is equal to the atmospheric pressure.
Children, from all that we discussed right now, it is quite clear that the boiling point of a liquid depends upon the atmospheric pressure. As the atmospheric pressure changes, the boiling point also changes accordingly. The boiling points of different liquids are generally expressed with respect to standard atmospheric pressure, that is 1 atmosphere. Children, since the boiling point of the liquid is linked with the external pressure, it can be made to boil at a temperature higher than its normal boiling point by increasing the external pressure or the pressure on its surface. ਕੰਟੇਨਰ ਦੇ ਵਿੱਚ ਰੱਖੇ ਲਿਕੁਇਡ ਦਾ ਟੈਂਪਰੇਚਰ ਹੀਟ ਕਰਨ ਤੇ ਵੱਧਦਾ ਰਹਿੰਦਾ ਹੈ ਜਦੋਂ ਤੱਕ ਕਿ ਇਹ ਉਬਲਣ ਤੱਕ ਨਾ ਪਹੁੰਚ ਜਾਵੇ। ਇੱਕ ਵਾਰ ਜਦੋਂ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਆ ਜਾਵੇ ਤਾਂ ਲਿਕੁਇਡ ਦਾ ਟੈਂਪਰੇਚਰ ਕਨਸਟੈਂਟ ਹੋ ਜਾਂਦਾ ਹੈ ਭਾਵੇਂ ਕਿ ਇਸ ਨੂੰ ਹਾਲਾਂ ਵੀ ਹੀਟ ਕੀਤਾ ਜਾ ਰਿਹਾ ਹੋਵੇ। ਅਸਲ ਵਿੱਚ ਜਦੋਂ ਲਿਕੁਇਡ ਨੂੰ ਗਰਮ ਕੀਤਾ ਜਾ ਰਿਹਾ ਹੁੰਦਾ ਹੈ, the energy supplied increases the average kinetic energy of the molecules present, ਜਿਸ ਦੇ ਕਾਰਨ ਲਿਕੁਇਡ ਦਾ ਟੈਂਪਰੇਚਰ ਵੱਧ ਜਾਂਦਾ ਹੈ। ਇਸ ਦਾ ਮਤਲਬ ਹੈ ਕਿ ਕਾਈਨੈਟਿਕ એનર્ਜੀ ਟੈਂਪਰੇਚਰ ਦੇ ਪ੍ਰੋਪੋਰਸ਼ਨਲ ਹੁੰਦੀ ਹੈ। ਇੱਕ ਵਾਰ ਜਦੋਂ ਲਿਕੁਇਡ ਉਬਲਣਾ ਸ਼ੁਰੂ ਹੁੰਦਾ ਹੈ ਜਾਂ ਉਹ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਤੇ ਪਹੁੰਚ ਜਾਂਦਾ ਹੈ ਤਾਂ escaping molecules ਦੇ ਕਾਰਨ heat energy now supplied compensates the loss of energy. ਇੱਥੇ molecules ਦੀ average kinetic energy ਵਿੱਚ ਕੋਈ ਤਬਦੀਲੀ ਨਹੀਂ ਹੁੰਦੀ ਅਤੇ ਲਿਕੁਇਡ ਦਾ ਟੈਂਪਰੇਚਰ ਉਦੋਂ ਤੱਕ ਨਹੀਂ ਬਦਲਦਾ ਜਦੋਂ ਤੱਕ ਸਾਰਾ ਲਿਕੁਇਡ ਵੇਪਰਸ ਵਿੱਚ ਨਹੀਂ ਬਦਲ ਜਾਂਦਾ। Children, let us now learn about differences between boiling and evaporation. Let us first discuss about boiling. Children, let us try to define boiling. Boiling takes place only at a specific temperature known as the boiling point, at which the vapor pressure of a liquid is equal to the pressure on its surface, that is atmospheric pressure. Let us now try to learn about evaporation and try to define it. Evaporation is a surface phenomenon and it takes place only from the surface of the liquid. It is a slow process and takes place spontaneously at all temperatures. Let us next learn about surface tension of liquids. Surface tension is an important property of the liquids, which is linked with the presence of intermolecular forces in them. It relates to the surface of the liquid. The molecules on the surface of the liquid behave differently than those present in the interior.
A molecule well within the liquid is attracted equally in all directions by the surrounding molecules. As a result, the net resultant pull on this molecule is nil, as shown in the animation. But the same is not the case with the surface molecule. It is being pulled by the molecules below and beside it. Since no molecules of the liquid are present above it, this leads to an imbalance of forces at the surface of the liquid. In other words, the molecules present on the surface of the liquid or the surface as a whole is under tension because of the inward pull by the molecules. This is known as surface tension. The inward pull tends to contract the surface of the liquid. As a result, the surface of the liquid behaves like a stretched membrane. Surface tension may also be defined as the tangential force acting along the surface of the liquid at right angles to the surface along 1 centimeter length of the surface. Because of the surface tension, the surface of the liquid tends to have the smallest possible area for a given volume. In order to increase the area, some work has to be done against the inward pull. Surface tension may also be defined as the work that must be done to increase the free surface area of any liquid by 1 unit at constant temperature. The SI unit of surface tension is joules per square meter or Newton per meter. The CGS unit of surface tension is dyne per centimeter. The two units are as related.
1 Newton per meter is equal to 10 to the power 3 dynes per centimeter.
For example, at 298 Kelvin, the surface tension for water is 72.8 Newton per meter.
The surface tension of a liquid depends upon the few factors. Let us discuss them one by one. Temperature of the liquid. Surface tension decreases with rise in temperature. As the temperature of the liquid increases, the average kinetic energy of the molecules present increases. This results in decrease in intermolecular forces of attraction also, and decreases in the value of surface tension. Nature of the liquid. The surface tension of a liquid is linked with the intermolecular forces of attraction present in the molecules of a particular liquid. The greater the magnitude of such forces, more will be the value of surface tension. Children, let us now learn about important consequences of surface tension, in which we will discuss few important consequences. Let us discuss first spherical shape of liquid drops.
The spherical shape of the liquid drops is because of surface tension. It tries to decrease the surface of a liquid to the minimum. Since the sphere has the minimum surface area for a particular volume of the liquid drops are spherical in shape, as shown on the screen. Let us now discuss about capillary action. If a capillary tube is dipped in a liquid like water which wets glass, the liquid rises into a capillary tube to a certain height. This is known as capillary action. This action is because of surface tension. The inward pull acting on the surface molecules pushes the liquid into the capillary tube. The capillary action is also responsible for the rise of oil in the wick of an oil lamp and of water below the surface of the earth in the plants through their roots. Meniscus of a liquid. ਜਦੋਂ ਲਿਕੁਇਡ ਨੂੰ ਇੱਕ ਕੰਟੇਨਰ ਵਿੱਚ ਰੱਖਿਆ ਜਾਂਦਾ ਹੈ ਤਾਂ ਉਸ ਦਾ ਸਰਫੇਸ ਕਰਵਡ ਸ਼ੇਪ ਲੈ ਲੈਂਦਾ ਹੈ, ਜਿਸ ਨੂੰ ਕਿ ਮੈਨਿਸਕਸ ਕਹਿੰਦੇ ਹਨ। ਪਾਣੀ ਸਮੇਤ ਜ਼ਿਆਦਾਤਰ ਲਿਕੁਇਡਸ ਦਾ ਮੈਨਿਸਕਸ ਕੌਨਕੇਵ ਹੁੰਦਾ ਹੈ, ਪਰ ਮਰਕਿਊਰੀ ਦੇ ਕੇਸ ਵਿੱਚ ਇਹ ਅਲੱਗ ਹੁੰਦਾ ਹੈ। ਉਸ ਦਾ ਮੈਨਿਸਕਸ ਕਨਵੈਕਸ ਹੁੰਦਾ ਹੈ। ਮੈਨਿਸਕਸ ਦੀ ਇਸ ਖਾਸ ਸ਼ੇਪ ਨੂੰ ਫੋਰਸਿਸ ਆਫ ਕੋਹੈਸ਼ਨ ਐਂਡ ਅਡੈਸ਼ਨ ਦੇ ਆਧਾਰ ਤੇ ਸਮਝਾਇਆ ਜਾ ਸਕਦਾ ਹੈ। ਫੋਰਸਿਸ ਆਫ ਕੋਹੈਸ਼ਨ ਇੱਕ ਤਰ੍ਹਾਂ ਦੇ ਮੋਲੀਕਿਊਲਸ ਵਿੱਚ ਪਾਇਆ ਜਾਂਦਾ ਹੈ। ਇਸੇ ਤਰ੍ਹਾਂ ਫੋਰਸਿਸ ਆਫ ਅਡੈਸ਼ਨ ਡਿਫਰੈਂਟ ਤਰ੍ਹਾਂ ਦੇ ਮੋਲੀਕਿਊਲਸ ਵਿੱਚ ਪਾਇਆ ਜਾਂਦਾ ਹੈ। ਜਦੋਂ ਪਾਣੀ ਨੂੰ ਇੱਕ ਕੰਟੇਨਰ ਜਿਵੇਂ ਕਿ ਗਲਾਸ ਟਿਊਬ ਵਿੱਚ ਲਿਆ ਜਾਂਦਾ ਹੈ, adhesive forces present in the molecules of glass and water are stronger as compared to cohesive forces in the molecules of water. ਇਹ ਪਾਣੀ ਦੇ ਸਰਫੇਸ ਨੂੰ ਕੌਨਕੇਵ ਸ਼ੇਪ ਲੈਣ ਲਈ ਮਜਬੂਰ ਕਰਦਾ ਹੈ। ਮਰਕਰੀ ਦੇ ਕੇਸ ਵਿੱਚ ਇਹ ਉਲਟਾ ਹੁੰਦਾ ਹੈ। ਇਸ ਦਾ ਮਤਲਬ ਇਹ ਹੈ ਕਿ ਕੋਹੈਸਿਵ ਫੋਰਸਿਸ ਅਡੈਸਿਵ ਫੋਰਸਿਸ ਤੋਂ ਜ਼ਿਆਦਾ ਹੁੰਦੀਆਂ ਹਨ, ਜਿਸ ਦੇ ਕਾਰਨ ਮਰਕਰੀ ਦਾ ਸਰਫੇਸ ਕਨਵੈਕਸ ਸ਼ੇਪ ਅਖਤਿਆਰ ਕਰਦਾ ਹੈ।
All liquids or fluids do not flow with the same speed. Liquid like water, alcohol, kerosene oil, etc. flow rapidly, while others like honey, glycerol, castor oil, etc. flow very slowly. This clearly shows that every liquid has a certain internal resistance to the flow called viscosity. Thus, viscosity of a liquid may be defined as the internal resistance to the flow possessed by a liquid. The internal resistance to flow is due to intermolecular forces of attraction present in different liquids. If these are strong, the liquid is more viscous, and in case these are weak, the viscosity of the liquid is comparatively less. We have seen that the viscosity arises due to internal friction or resistance between the layers of a liquid as they pass over each other. When a liquid is flowing steadily over a fixed horizontal surface, the layer of the liquid is in immediate contact if the surface is stationary. With the increase in distance from the fixed surface, the velocity of the layers increases. In case we select a particular layer, then the layer present immediately below tries to retard or slow down its velocity, while the one immediately above tends to accelerate the same. The viscosity of liquid depends upon area of surface in contact, represented as capital A, velocity gradient, represented by dV upon dx. Therefore, force is proportional to area or surface in contact multiplied by velocity gradient, represented by dV upon dx, which is equal to eta multiplied by area or surface in contact multiplied by velocity gradient, represented by dV upon dx. Here, eta is called coefficient of viscosity. The coefficient of viscosity may be defined as the force applied per unit area in order to maintain a unit relative velocity between the two layers of a liquid at a unit distance apart. The reciprocal of coefficient of viscosity is known as fluidity. The viscosities of liquids are generally compared in terms of their viscosity coefficients. If coefficient of viscosity is small, the liquid is less viscous. If coefficient of viscosity is large, then the liquid is more viscous. The CGS unit of coefficient of viscosity is grams per centimeter per second, which is also known as poise. the SI unit of viscosity coefficient is kilograms per meter per second or Newton second per square meter. 1 poise is equal to 0.1 Newton second per square meter. Factors influencing viscosity of liquids. Viscosity of liquids depends upon the following factors. Temperature. The viscosity of a liquid is expected to decrease with rise in temperature, which will increase the average kinetic energy of liquid molecules, and therefore the intermolecular forces of attraction will be easily overcome, leading to decrease in viscosity. Nature of liquids. The liquids having stronger intermolecular forces of attraction are expected to have more viscosities than the liquids with weaker attractive forces. Today we have learnt about liquid state of matter, in which we learnt about different properties. Hope you enjoyed the lesson as much as I did. See you next time. Till then, bye.